Okay, this is a refresher from what you should have learned or in the Chem 6 series and how these significant figures work for a variety of operations. So let's talk about that. So what numbers, first of all, are significant? Well, of course, any number 1 through 9 are always significant. So if you have these numbers, anytime you see a number like this or any numbers joined together, those are all significant, okay? The real key is 0. When is 0 significant? When is it not significant? Okay, so let's go into that. Leading zeros are never significant. So these leading zeros not significant, not significant. Leading zeros through a decimal place also not significant. So all of these have one significant figure. Okay. Zeros that are sandwiched between two other numbers that are not 0 are always significant. So here, those two zeros between there are significant. So there are 4 sig figs. That 0 there are 3 sig figs. Right here, 3 sig figs. There are 4 sig figs. There are 5 sig figs. So if it's leading, it's never. If it's in the middle, it's always. And when it's trailing to the right, it's sometimes. So let's see when this is. So normally, trailing zeros on large numbers are not significant. So for example, these trailing zeros are not significant. They're telling you how far that 1 is over. So each one of these measurements has 1 sig fig, right? Those zeros are not significant. Once you put a decimal place here, however, it is telling the person who's looking at this number that all those zeros are significant and that 0 right there is significant. And because it's significant and there's a 1 there, all zeros in between it are significant. So this has 4 sig figs, 3 sig figs, and 2 sig figs. Any zeros after a decimal place are always significant. So 2 sig fig, 1 sig fig, 2 sig figs, 3 sig figs, 4 sig figs. So no decimal place, not significant. Decimal place keeps them significant. Anything to the right of the decimal place, significant. So to recap, leading zeros don't count towards the sig fig. Zeros between always count, and trailing numbers sometimes count. So if there's no decimal place, these don't count. If there is a decimal place, they do count. Let's say maybe you want to say this place is significant, but not the last one. So if I put a decimal place there, that would make that significant. That's not what we want. You can put a bar over it, or better yet, write it in scientific notation. See, that's a 0 trailing past the decimal place. So you can see that there's 3 sig figs there, just like there's 3 sig figs there. And lastly, any zeros after a decimal place are significant. So what actually, we keep talking about, hey, there's sig figs and we have some sort of number. So what does this actually mean, right? And so in science, right, when we have a number contains all the certain digits and the first uncertain digit. So what does that mean? In this number, 23.45, the 23.4 are certain. Those, which means we know that they will never change. Okay? This last number right here is an estimate number, right? That's where our first kind of uncertainty plays in. So this means this number could probably range as large as 23.46 or as low as 23.44. Okay? So that's what that last digit means, that first uncertain digit. It is uncertain. It could go up a little or it could go down a little. There's wiggle room in that number. And that's what a number means in science. So let's look at this in terms of addition. So when we add things together, we always have the largest error dictates what the answer, where the error in the answer is. Well, so whether it's number of decimal places to the right or just any space in general, we just want to look at these and see where our uncertainty is, right? That number can wiggle by 1, right? This number can wiggle by 1. That wiggle can wiggle by 1. So what's the biggest wiggling number here, right? The biggest uncertain number is this one, right? So right, if you don't know if you have, I have somewhere, let's say I have $30, which means I have somewhere between $20 and $40, right? If I said I had 31, right, this one, or added $1 to it, let's say I added $1 to that 30, you could have anywhere from $21 to $41. You don't know. So we're not even going to, if you add 1 to that, we're still going to leave it as is, right? It's not significant enough. The wiggle, right, the uncertainty is smaller. So we're going to keep the largest uncertainty. There's the largest uncertainty. We're going to keep that. And then we're going to take that next number and we're going to round it up. So our answer here would be 855.41 when we added these together. Apparently that's a 6. It's the same with subtraction. We're going to take the largest uncertainty. Here our largest uncertainty is at 3 compared to that 8. So that uncertainty is here. That 6, right? When we look at this number, when we're gonna get rid of all these red numbers here, so when we have to look at it, does it round it up? And the answer, of course, in this one is yes, it rounds up. So our answer is minus 64.76. Well, what about multiplication? Well, multiplication is slightly different. We're going to take the number that has the least number of sig figs. So here we can see this one where our, right, there's no decimal place here, so that 0 is not significant, so we only have 2 sig figs here. Here we have 1, 2, 3, 4, 5, 6, 7, 8 sig figs. And here we have 1, 2, 3, 4, 5, 6, 7, 8 sig figs. Okay. What's it? Is that 1, 2, 3, 4, 5, 6? This is actually 7 sig figs. I miscounted. So that means our answer can only have 2 sig figs. So that means in our answer, right, 2 sig figs would be right here. That second sig fig, well, that's where our wiggle room is, right? That's our uncertainty. This is telling us our uncertainty has to be in the second significant figure. So if that's our second significant figure, right, then we have to look to the number left of it. Would it round up? And the answer is yes. So our answer is 2,200. Mind you, right, that's not the same as this, right? Right? That is totally different because this says, hey, this number could be as big as 2,300 or as small as 2,100. We don't know. By putting this decimal place there, you're implying it could be as big as this or as small as that. And that's a lot of high precision, and this is not. And that's exactly what we don't know because our error is in that spot. Okay? Same with division. Division and multiplication are handled the same way, right? We have 5 sig figs here. And here we have 6 sig figs. So that means we can only have 5 sig figs in our answer. So 1, 2, 3, 4, 5. That means that 5th sig fig is our uncertainty. And so as we look at that uncertainty, will that cause it to round up? And in this case, yes. So once again, we have to have 1, 2, 3, 4, 5 sig figs. And sure enough, we do. What about combinations, right? Nested. Well, we do PEMBA, right? The parentheses exponential, multiplication, division, addition, subtraction, right? So we have parentheses here. We'll do that one first, then we'll do the multiplication, and then we'll look at our answer. So each step, we just continue those rules. So the first one is an addition between these two. So here's our addition. And once again, we look at our largest uncertainty. And of course, it's going to be this 2 right there. We'll add them together. Now, when you do nested operations, you don't want to round now. If you round now, you're going to induce error. So that's bad. So you just want to remember, hey, my actual decimal place or my actual number that has uncertainty is this 4. So then I do the next operation, keeping the whole number, knowing that I have, now I'm doing multiplication, so I have 1, 2, 3, 4, 5, 6, 7 sig figs versus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sig figs. So the 7 sig figs is the smallest, so it wins. So when we do our answer, we have to keep 1, 2, 3, 4, 5, 6, 7 sig figs. That's where my uncertainty will be. Will that cause it to round up? Yes, it will. Right? So there we go. Now in Chem 7L, we're going to deal a lot with logarithms, right? We have to deal with pH, we have to deal with pKa, and we're going to learn something new called absorbance, which is the negative log of transmission. Okay? So how do we track significant figures in and through a logarithm? So classically, it's taught in the following manner. If you have some number, so 95,700, you can see I've turned that 7 green, so you can see where the first uncertain digit is. We can see that this has 3 sig figs. We can now take this and actually separate this number into 2 different numbers. We can separate it into what's called the mantissa and the characteristic, right? So all I did is take this number, I divided it by 10 to the 4th, which is the same as addition in logarithms. If you don't remember that, please review it. You are responsible for it because the prereqs are Math 10 and Math 20. So this is the same thing. So now we have 2 different logarithms. So we have a logarithm of something that's less than 10 but greater than 0. That gives us what's called the fractional component, or the mantissa. This part gives us the exact number, and it's called the characteristic, right? So when we add these 2 together, we're going to get the logarithm, right? Now, the thing is this. This part, the mantissa, actually carries the significant figures with it. This doesn't, okay? So if this has 3 sig figs and the uncertainty is in the 3rd digit, then our uncertainty here has to be in the 3rd digit as well, which means that will round here, and this will be our answer, okay? Antilogs are the exact opposite, okay? Now, normally when I explain it this way, students are like, yeah, I'm kind of lost, this sucks. So let's walk through how logarithms work and then see why it works this way. So I have a number here, 2.34. Pretty easy. Let's multiply that number by 10. 23.4. Not too bad. Let's multiply it by 10 again. 234. You can see each one of these has 3 sig figs, and the only difference is we're increasing it by a factor of 10. Well, let's take that 234 and let's write it in scientific notation. Still sig figs, 3 sig figs, and these 2 are, once again, the same number. Okay? Let's do one more. Let's go one more bigger. Let's multiply it by 10 again. Right? Each one of these is being multiplied by 10. So I have 2.34 times 10 to the 3rd. And then let's do like a big jump. Let's go 2.34 times 10 to the 12th. So, multiply by, a lot more 10s. Okay. So no big deal. And all of these, you can clearly see, have 3 significant figures. Okay? So let's take the logarithm of all these numbers. Let's do the first one. What is the logarithm of 2.34? If you put that in your calculator, you're going to get 0.369216. This number is telling you exactly what 2.34 is. This number represents the values of 2.34. Okay, so what's the logarithm of 23.4? Well, that's kind of interesting, right? It's just like 2.34, except for what? It's just 10 times bigger. Okay, so if you put that in your calculator, look what comes out. 1.369216. Huh, that's interesting. Everything to the right of the decimal place is the same, but now I've just added a 1 to it. Well, what happens when we multiply by 10 again? Oh, look at that. It's the same thing because the numbers are the same, 234, which is represented by that. And this 2 just tells me, look at that, I multiplied by 2 10s. Maybe you're starting to see a correlation here, right? And when we talk about sig figs, we only talk about the number, right? We talk about these having significant figures. We never talk about this 10 to the 12th or 10 to the 3rd or 10 to the 2nd. We don't count this with significant figures because really it's just the number of zeros behind it. And that's exactly what everything to the left of the decimal place is. These are the same as this. There's no difference. Because these are the same, we don't count these for sig figs. We don't count those for sig figs, right? They're the characteristic. The only thing that we count with sig figs is what represents these numbers. So if I have 3 sig figs here, I have to keep 1, 2, 3 sig figs here. So what's that look like? So there we go. There's all the sig figs, right, with the least certain digit, right, the first uncertain digit. And then, of course, these 2's do not round. So you can see these are the logarithms for all these numbers. These have 3 sig figs. These all have 3 sig figs. Sig figs are just counted as decimal places in a logarithm to the right of the decimal place. These have 3 numbers to the right of the decimal place. So even though it has 5 numbers, it only has 3 significant ones because this 12 is identical to 10 to the 12th. Okay? And this works in reverse as well, right? So if I was doing an anti-log and I had 10 and I raised that to the 12.369, I know this is a logarithm, so this only has 3 sig figs. So when I do the calculation, I know that I can only keep 3 sig figs. Okay? It's forward and back is the same thing. Okay. Now the big problem that students will have is what happens if there's zeros here? Or let's say this was a 0.069 or whatever. What does this mean? How do we count it? Is that 3 sig figs? Is it 2 sig figs? Because, Professor, you told me that leading zeros never count. Leading zeros don't count in normal numbers. But once you take a logarithm, they count. Well, how can we prove this to ourselves? Well, let's try that. Here's a very easy number, 1, right? This number 1 has how many sig figs? 1. How about 1.0? This is also 1 if you were to put it in your calculator. But it is 2 sig figs, right? Because this is the first uncertain digit. This could be as big as 2 or as small as 0, right? This uncertain digit here means this could be as big as 1.1 or as small as 0.9. This has 3 sig figs. This one could be as big as 1.01 or as small as 0.99, right? And so on, okay? So 4 sig figs, 5 sig figs, they're all 1. So if we were to take these and put these in your calculator and you take the logarithm of 1, you get 0 back. Okay, so all of these are going to return 0. So how do I tell how many sig figs there are? If I want to go backwards, if I want to take the 0 and go 10 to the 0, how do I know I can stop at 1 or do I have to go to 1.00? How do I determine that? How do I count significant figures in 0 in a logarithm? Well, it's really easy. Remember, we said any digits to the right of the decimal place are the sig figs. So I have 1 sig fig here. I have 1 0 to the right of the decimal place. Any digit to the right of the decimal place in a logarithm is a significant figure. I have 2 sig figs. I have 2 zeros to the right of the decimal place. I have 3 sig figs. I have 3 zeros to the right of the decimal place. I have 4 sig figs or 5 sig figs. So now, when I want to do the inverse log and I have 0.000, I know that I have to have 3 sig figs, and so that this goes to 1.00, right? I can keep that level of precision, that level of error in my number. So any zeros count. Okay, so let's test your knowledge. The logarithm of 1.12 is on your calculator 0.04921802267. Which one of these, A, B, C, or D, is the correct way to write that logarithm? Pause the video and give it a try or get a guess. Okay, so we're taking a logarithm of a number. This number has 3 sig figs, which means in our number, we need to keep 3 sig figs. Logarithms are digits after the decimal place, just like we did with zeros. We need to keep 3 digits. So the answer is A. If you screwed up, you most likely pick B because you're like, oh, leading zeros. And in case this would be incorrect. Because remember, if this is 3 sig figs, then that 0 counts. That's 3 sig figs. Okay, so let's look at nested significant figures calculations. So in this case, we have a logarithm and we're adding it to something. So we still have to track significant figures and add things together and watch where uncertainty is. So of course, the first thing we're going to do is we're going to say, hey, we're going to take the logarithm. This has 4 sig figs, so we need to keep 1, 2, 3, 4 past the decimal place. So there's our uncertainty, but we can't round at this point, right? We don't want to round in the middle of a calculation. So now we're going to add it to the other number. You can see that our largest uncertainty is here. There's the 9. So that transmits down to the 4. And of course, this 7 will have us round. And our answer will be 1.0725. And these are the basics of significant figures. What a significant figure means. Remember, it's all the certain digits plus the first uncertain digit. And this is the math that you're going to need for this course.